right, class. Today we are extending our exponent knowledge by another little trick. We're going to do power to a power property. Now, take a look at this first little example. We have x squared cubed. And I say, what does that mean? Well, that means I'm going x squared 3 times. So I'm going x squared times x squared times x squared, which tells me then that using the multiplication property we learned yesterday, that turns into x to the 2 plus 2 plus 2, which is x to the 6th. Now I want you to try to see a pattern between this number and these two initial numbers. Let me erase this for a second. And these two numbers. Let's test our theory. This is just, okay, I should have done this first. 5 cubed means 5 times 5 times 5. So anything inside here cubed would mean whatever it is times whatever it is times whatever it is. I happen to call that blob. Blob times blob times blob. Okay, this is just going ahead and extending that. What we just discovered, we don't even need that. Here I want you to test your hypotheses. If we have w cubed cubed, now remember, if we had blob cubed, it meant blob times blob times blob, okay? Whatever it is in there. Well, here we have w cubed, that's what's in there. So it's going to be w cubed 3 times w cubed times w cubed. Using our multiplication property, that turns into w to the 3 plus 3 plus 3, which is w to the 9th. Now look at the 9 and look at the hypotheses you made before. Does that match? Are you seeing a pattern? What can I do with those two numbers to get to 9? There is a trick. I want you to think, pair, share with your partner, table partner. Share what you think the rule is. And let's see. It's called a product of a power property. And this property states that if we have any base to a power, a to the n to the nth power is equal to a to the n times n. Repeating. A to the n to the nth power is equal to a to the n times n. Say it. A to the n is equal to a to the n times n. I'm hoping that's a pattern that you noticed. It's very effective and very easy to get it confused when I start combining things. What students start getting stuck on now is when do you add, when do you subtract? What I tell most of my students, anytime you see a parenthesis going on, it's just like distributing. And when you distribute, you multiply. And distributing means multiply. Okay, let's do it. W to the 4th to the 11th times x to the 9th squared. Well, this would equal, simplifying that out, w to the 4 times 11 times x to the 9 times 2. That turns into w to the 44 times x to the 18th. Keep in mind that we cannot combine these two because w and x are not the same base. So this would be our final answer. All right, let's do another one. I actually want to do multi-step examples after I'm done with this, but let's go ahead and go 6 squared to the 5th power. Okay, so I have 6 squared to the 5th. That would equal 6 to the 2 times 5, which is equal to 6 to the 10th power. If I had a to the negative 2 times 5, now we're going to be combining That lovely word scaffolding, I'm scaffolding from your previous knowledge. This turns into a to the negative 2 times 5, a to the negative 10. I am not simplifying. This then, we don't want a negative exponent, so we kind of put that on the bottom. This is 1 over a to the 10. We're going to combine even more. Watch this. This is going to be craziness. 3 times a squared to the 4 times a to the 5th. Look at that. Again, I'm going from your previous knowledge. Well, here's our new knowledge. I have a squared to the 4th, not the 3. The 3 is just out of there. It has nothing to do because it's not inside the parentheses. This turns into 3 times a to the 2 times 4 times a to the 5th, which is 3a to the 8th, a to the 5th, which is 3a to the 13th. Because I utilized my multiplication property of exponents. And that's about how difficult it's going to get. Trust me, it seems easy while I'm doing it, but once you have to start isolating these skills yourself, it does get difficult. I want to do another example. Feel free to work with me. We're going to do 4x squared cubed times 3. I don't want to do times 3. I want to do times x to the negative 15. All right, we got a few things going on. Distribute my power, so that would turn into 4 cubed x to the 6th times x to the negative 15. That turns into 4 cubed times x to the negative 9. I need to get rid of this negative exponent. That is 4 cubed over x to the 9th. That would be our final answer. All right, we're going to do one more. I want you to go 3a squared b to the negative 2 times a to the 4th b all to the negative 1. This is going to be our last example that we do, and then you're going to work independently on this. The first thing, my first plan of attack, and I don't know if you want to write this in your notes, it's just like solving normal problems. You want to distribute first. That's always what I'm going to do. So I'm going to rewrite everything because I am not lazy. It's not a big deal to rewrite. A to the 4 times negative 1 is negative 4. B, this is like a 1. Negative 1 times 1 is negative 1. Now I'm going to combine like terms. It's just like solving a problem. So secondly, I'm going to add exponents if I can. Okay, so I get 3 to the a, 2 plus the negative 4, times b to the negative 2 minus 1 turns into 3a, so what's that, negative 2, b to the negative 3. I have negative exponents. They are going to get replaced. So I have 3 left on top. A squared b cubed, final answer. All right, that's about it for today with your examples. You're going to want to make sure that you work through your worksheet, take your time, reference this video again online if you need it this weekend. The sub does have a key if you would like to check your answer, see if you're right. Work independently. If you are done, you can work on IXL. I do not want free time and there is no games. So you should understand your expectations. This is due on Monday.